Hello everyone. In this video series, I'll be discussing some of the Simulink models for electrical circuits. I'll be telling you how to draw and use Simulink for implementing different electrical circuits. So let us take an example and try to implement this simple circuit on Simulink. So in this first circuit, we have to implement a single phase RL, that is resistance inductance series circuit. The diagram, the circuit diagram is given over here. So it consists of resistance and inductance connected in series. We are also given with the specifications of this circuit. So the supply voltage will be an alternating current or a AC supply, and the voltage should be 100 volts. The value of resistance is 10 ohms and the value of inductance is 0.1 Henry. The frequency is 50 Hertz. So for this particular circuit, we have to implement a Simulink model and calculate the voltage drop across the resistor VR, the voltage drop across the inductor VL, the current flowing in the circuit, and the phase angle or the phase difference between the two voltages. Also, we have to calculate the active power P and the reactive power Q for this circuit. So let us have a look at how we can implement this circuit and take all these measurements on Simulink. So if you click on this MATLAB icon and open MATLAB, so it will open this type of a window on MATLAB. Now if you click on the home button, you can find the option to Simulink. So if we click on it and open the Simulink, it will open this type of a window for you. So since we are making this circuit, so we have to create blank model. So if you click on it, it will open this type of a blank model or blank Simulink model for you. So let's maximize this. So once you open this blank Simulink model, you will get this option for new, open, save, print, which are obvious. The next thing you can find on the top is your library browser. So the first thing, if you open the library browser, you'll find so many. If you go into library, the first thing that I would like you all to check is whether your Simulink, it has Simscape electrical. Okay, so that you can do by going into apps and get add-ons, and by typing Simscape electrical, this one. So since it is already installed on my computer, I don't need to install it again. But if it is not installed, please do install it. Okay. So this library browser or this library, it will have all the components that you need. So to implement the circuit, the first thing we need is an AC voltage source. So what you can do is you can type in AC voltage source, and if you press enter, it will give you all the components which are available. So we are going to choose this black one, and to bring it onto the main screen, you can just click on it and drag to the main screen. So that, there you go. So you have the AC voltage source. Now one thing which I will do is I will right click on it and go into format and show block name. So I will turn it on. Okay, so I can see which component they are. Okay, so we have the AC voltage source. The next thing we need is series RLC. So this is your series RLC branch. So again, you click on it and drag and drop it on the main screen. Again, I will turn on the block name. Now, so I would like to rotate this block series RLC branch to connect it. So one way you can do is you can right click and then go into format and rotate it clockwise, something like this. Okay, and we would like to connect the two. So as soon as you bring your cursor next to the component or the end of the component, you can see that it turns into a plus sign. Okay, so you just have to click and hold your cursor and you can connect it. Okay, now so I have my voltage source and the RLC series circuit. Now the next thing is I would like to change the values. So what I've done is I've double clicked on it. Okay, first let's change the parameters of supply. So the peak amplitude is 100, which is okay, but I want to change the frequency, the supply frequency, to 50 Hertz. Okay, then you click on apply and okay. Now the next thing is I want to change the values of this series RLC. So what I'll do is I will double click on it and that opens the parameter for this block. So from branch type, I only need resistance and inductance connected in series. The value of resistance is 10 ohms and the value of inductance is 0.1 Henry. So please note that the resistance, the unit of these values, of these parameters, they are constant. So resistance is always in ohms. So if you have a resistor of kilo ohm value, you have to enter the value accordingly. And the same goes for inductance. So inductance is in Henry. Okay. I can click apply and then okay. Right. So I have my basic circuit ready. So this was the circuit that I wanted to implement. But the next thing I want to do is take some measurements. So first I have to measure the current in the branch. So what I'll do is I'll search for current measurement and click enter. So this is the current measurement that I am going to use. So current measurement, it is kind of a ammeter, you can say, and we can use that block to measure the current. So I have to connect this current measurement over here. Okay, and then the next terminal would go in here. So this way I have to uh, connect the current measurement. Now to display the values, I can connect uh, a display, but that will display, since you have a AC voltage source, so that will display all the values. Okay, so alternating current, it changes its value according to time, right? So you will have so many values. So we need the RMS value. Okay, so let's search for true RMS. Okay, so this block, if we connect it here, okay, and then we can connect the RMS value to a display. So again I will search for display, and I want to check the number, right? I want to see the number value, numerical value of RMS. So I need to go down, and this is the display that I will select. Okay, so I've just dragged and dropped it. So there you go. So this is my RMS current. Okay, so I will turn on the block name, and I will change it to uh, current. Okay, now the next thing I want to measure is the voltage across the resistor and inductor. Okay, so similar to current measurement, we have something called as voltage measurement. So I will need two of these. So one I'm going to connect it here, and I will turn on the name, show block name on, and change it to VR. Okay, the voltage across resistor. Now I can copy and paste it. So I've selected the block, and I'm going to copy it, and Control C and Control V. Okay, so I have my two oops, blocks here. So let's see. Okay, so it doesn't allow me to connect between the resistor and the inductor. So I'm going to make some changes in the diagram. So I will double click on it and change it to resistance only. Okay, resistance of 10 ohms. I'm going to copy it and paste it, and this one will be my inductor of 0.1 Henry. Okay, just let's reduce the size here, and I need to delete this one. I'll shrink this one as well, and we can connect it. Okay, and then connect it here. Okay, so I can name it as resistance equal to 10 ohms, and this one as inductance, that is L equal to 0.1 Henry. Okay, so now I should be able to connect it somehow. Let's see. There we go. And this one, I can connect it here, bring it like here, and the other one goes there. Okay, so I have my AC voltage supply, all the current and voltage measurements. Now, in obviously you can connect a RMS and a display to check out the numbers, the RMS voltage across the resistor and the uh, RMS voltage across the inductor VL. Okay, but in the question, or according to our question, we need to measure the peak voltage and we need to calculate the phase difference. So instead of connecting it to a numerical display, I will search for an oscilloscope. Okay, and connect the two voltages to this scope. Okay, however, as you can see, this has only one input, so you can double click on it. So if you double click on it, it will open this type of a graph, and if you click on this configuration property or this cog wheel on the main screen itself, you will get the option to change the number of input ports. So I'm going to change it to 2. Okay, so as you can see, now it has 2 inputs or 2 channels. Okay, so one of the channel I'm going to connect it to VR and the other one to VL. Right, so my circuit is nearly ready, but the thing is you would need another component, which is power GUI. Okay, so this component, it will not be connected to any part, but it has to be there, right? So it kind of initiates the lab view and kind of tells it that this is a electrical power circuit. So it defines those boundaries. Okay, now another thing which I've missed is to change the frequency. Okay, so before running your simulation, just check if you need to change any frequencies. Okay, uh, so just this one is okay, and these voltage and current measurement, you don't need to change the frequencies. You won't get the option to change the frequency. Now, so my frequency is 50 hertz, and let's say I want to check three waveforms, right? So the time period for one waveform will be t equals to 1 divided by f, that is 1 divided by 50. That will come out to be 20 milliseconds. Now I want 3 cycles, so 3 cycles will take 60 milliseconds. So what we can do is we can change the stop time to 0.06. Okay, and now if we try and run our circuit, right? So on executing or running this circuit, the value of current flowing in the circuit is 2.15 amperes. Okay, that's the RMS current. And if we double click on the scope, we can see the two waveforms. So one of them belongs to the voltage across the resistor, and the other one belongs to the voltage across the inductor. Now if I click on this configuration, what you can do is you can also change the layout, the way these waveforms they are displayed. Okay, so there you go, you get two waveforms like this. So for the time being, I'm going to change it back to a single. Okay, if I go into layout, you can, from there also you can change the layout, how the waveforms are displayed. Another thing which you can do is you can click on this show legend. Okay, so it should display the corresponding color. There we go. So now we can see VR is yellow, that is the voltage across the resistor is yellow, and the voltage across inductor is blue. Now what you can do is you can click on cursor measurements. Okay, so what it will do is it will enable the cursors. So if you click on the cursor measurements, it will enable the cursors. Okay, so let us first measure the um, the peak voltages. So for the time being, I'm going to disable the vertical cursors. Okay, so the second cursor, I'm going to try and adjust it to the peak somewhere 95.6 is the peak value for the voltage across inductor, and it is around 30.5 across the, or the peak value, peak voltage across the resistor is 30.5. Okay, now to measure the phase difference between the two voltages or the waveforms, what I'm going to do is I've enabled the vertical and waveform cursors, these two options. So this will trace the waveform. So if I'm moving cursor 1, it's moving along the VR waveform. Now the second cursor, I'm going to change it to VL. Okay, and if I move it somewhere here, this should be probably the middle. So approximately 15 millisecond, the value of delta t, it's coming out to be 15 milliseconds. Okay, so using that time difference, we can calculate the uh, phase difference. Now, if I come back to the slides, and we have done some calculations here to verify the measured value using Simulink. So you are given with the frequency and the inductance value. Okay, so we can calculate the inductive reactance. Okay, and since we have calculated the inductive reactance and the resistance value is given, so we can calculate the impedance of the circuit. So that comes out to be 32.97. Okay, using this impedance, we can then calculate the current flowing in the circuit. Now over here, the value of current, it is coming out to be 3.03 amperes. And in the Simulink model, we are getting around 2 amperes. So we should note that the value in the Simulink model is the RMS value, root mean square. So if you divide this current 3.03 divided by square root of 2, we can get the RMS value, and it would come out to be around 2.1 amperes or something like that. You can verify it. The next thing is the voltage across the resistor. So we know the current, we know the voltage, so we can calculate the voltage across the resistor. So this is again the peak voltage, and from the waveform we have just now verified, it's around 30 volts. The voltage across the resistor is 30 volts. And similarly, we can calculate the voltage across the inductor. So that comes out to be 95 volts. Okay. Now this phase angle, it is minus, or the phase difference over here, it's coming out to be minus 72.34. So if you convert it into a positive angle, that will come out to be 287.6 degrees, a positive degree. Now using this formula, we can calculate the time delay. So from the Simulink, we were getting that time delay, right? We were getting 15 milliseconds. And frequency, we already know it's 50 hertz and multiplied by 360 degree. So if you do the calculation, you would get something around the same angle. Okay, phase angle will be similar to what we have calculated. Then also in the Simulink model, we have to calculate the active power and the reactive power. So I have not shown it to you, but let's quickly check out the values. So the active power, if you do the calculations, it comes out to be the RMS value, it comes out to be 45.99 watts. Okay, so we can go back to the Simulink model and implement that power measurement. So basically the block you need is called power measurement. Okay, so this one, first one is a three phase, the second one is your single phase. Okay, so I can click and drop it here. So now I would need the voltage and the current. Okay, so what I can do is I can just move it a little up here. Okay, and connect the current, and also we need to measure the voltage across the supply. So we would need another voltage measurement. So I can just copy it here and paste it. Okay, so let's call this as VS, the supply voltage, and connect it here, and then connect it something like that. Okay, now so these are, as you can see, these will be uh, analog inputs. So I would need the RMS and the display. So what I can do is I can just select both of them and paste one across here, and the other one across here. Okay, okay, let's see. Okay, power measurement. I have to change the frequency here. Okay, so RMS values, the true RMS blocks, they have 50 hertz frequencies, fundamental frequencies. So I don't need to change it. Okay, now if you click this icon, as you might have noticed, it automatically adjust the screen to my current circuit. It displays all the components in my current circuit. Okay, so as you can see, the the true power, it is 46 and Q is 144.5. So these are again the RMS values. Okay, if we go back to the slides, uh, you can see the active RMS power is 45.9 watts, and the value of Q, the reactive power, is 144.5, right? So that's what we were getting in the circuit, right? So that's your first circuit. We will take up few more circuit. So in the next video, we will take a parallel circuit. Okay, we'll take up this circuit and try to implement it in Simulink. Similar circuit, but now the resistance, inductance and capacitance, they are in parallel. Okay, so that's it for today. Thank you for watching this video.